XR evangelist. So that means I basically focus on kind of new and emerging technologies, AR, VR, go around, give some talks at conferences, and develop a lot of sample applications. So there's my email address as well as my Twitter handle. And so this is kind of the overview of what I'm going to be talking about today. So I'm going to go over just a brief overview of what the AR landscape is currently, what's kind of out there, what's still in development, and then talk about how these mobile SDKs actually work. What's going on behind the scenes, what problems have those platforms holders solved. Then just kind of go into the current feature set of what is available in the AR SDKs, and then start talking about some tips and considerations, some things for kind of improving your workflow, or just things to consider when building augmented reality applications. Next, I'll just go over some example use cases, some kind of interesting things that I've seen out there that people in the community are developing. And then I'll show some demos that I've developed, kind of walk through how those work, what sort of things I was doing. And then lastly, look at kind of a future of AR inside Unity, some of our plans that we're developing, and some things to expect down the road. So I'm going to start off by kind of just saying, what is augmented reality? So the idea behind augmented reality is just putting digital objects in the real world. So all of these devices or headsets have kind of a view into the real world, and then using different sensors and information, they're kind of understanding the world around them and augmenting objects in them. So what that means is that the more you know about the world, the better you can kind of sell or better place these objects in the world. And there's different features and kind of things to consider when placing objects there. So the current kind of AR landscape that we have right now, I've kind of split it into two categories here. We have head-mounted displays, things like the HoloLens, which is kind of its own self-contained one with a transparent display that you can view the real world into, and then it projects holograms in front of you. The Meta is similar to the HoloLens, except it's tethered to a desktop PC. Again, kind of a transparent display. And then we have the Magic Leap. We don't really know much about it, but we do know it's in development, and they've claimed that it's an augmented reality headset. And so on the flip side, for mobile SDKs and solutions, we have Viewforia. And we're actually a close partner with Viewforia, and they allow you to, again, look into the world. And they started out with kind of marker-based augmented reality. So you recognize an image or a QR code type thing, and then you can augment objects on top of that. But the nice thing with Viewforia is that you can actually track any objects, and it's expanded beyond just QR codes now. And then next we have ARCore, which is the AR solution developed by Google for the Android platform, and ARKit, which is the AR solution developed by Apple for the iOS platform. And that's kind of what I'm going to be focusing this talk on here today. All right, so how does it work? Basically, if you've been following the news or you're kind of informed on where these things came from, it kind of seems like they really came out of nowhere. Apple announced theirs at their conference, and then Google had some AR solutions with Tango, but then kind of reverted back and released ARCore. And so the big idea here is something called visual inertial odometry. And what that is it's basically the kind of culmination of using IMU sensors in the device. So that's things like the gyroscope and accelerometer to understand its position and orientation, along with computer vision to kind of analyze and understand the world. And so when these things come together, this allows you to move around the world, kind of track where you're at, and use your position as you walk through the world. And then there's computer vision that's analyzing kind of the image that you're getting into your device, and then all those sensor data from the IMUs are coming back and kind of doing a dead reckoning to try to position you accurately in the world. And so a big part of this is something called AR anchors, or they have a little bit different kind of name depending on what platform you're on, but the basic idea is the same. And it's that as you kind of scan and move around the world, your device and the computer vision starts to recognize feature points. And so a feature point is kind of a broad term of anything that the computer thinks is kind of interesting or different than things around it. So if I was kind of looking around this podium, a feature point could be the corner of this object here, it could be the corner of my laptop, kind of interesting points that are different than other things around it. If I was looking up against that brown wall over there, it'd be actually really difficult to get any feature points if I was up close to it, because it's all kind of very similar in shade, and there's not really any identifying components there. But what happens is as you move around and as you start to kind of walk through the world, the devices build up these feature points, kind of remember them throughout the world, and then this is how you orient yourself. And when you're placing digital objects in the world, most of the time you're actually kind of placing them relative to these anchors. So if you think in Unity terms, you kind of have an anchor as the parent, and you place things in the relative child position around that to kind of position them there in the world. All right, so the core features right now of these mobile AR SDKs are plane finding, and so that's kind of, you know, scanning, looking around the world, finding feature points on the relatively same horizontal axes, and then from there it determines that a plane is found. And I'll talk a little bit more about these in a moment here. The next one is hit testing, which is basically just using the computer vision to analyze what you're actually looking at, and then casting kind of rays or you know, points into the world to generalize the depth of what you're looking at. And lastly, light estimation. So a big part of kind of selling, you know, these augmented objects or these things you're putting into the world is lighting them and you know, shading them similar to what the world is lit and shaded. And so they all offer kind of slightly different solutions for that. And then the last thing that I don't have listed here is just basic positional tracking. And that's using what I mentioned earlier with the visual inertial odometry and how it allows you to kind of move around in the world there. All right, so plane finding. So the you know, I've mentioned that, you know, this is about ARCore and ARKit, but those main features that I just listed are basically kind of feature parity, where both SDKs have similar features and they do similar functionality. Now there is going to be some slight, you know, visual differences as well as just how things are implemented, but again, the general features are the same. And so with ARKit, you can see that top picture there. It basically spawns a prefab in the scene, and it then starts to extend around and kind of form around the position and rotation of the anchors that you find. And the nice thing about ARKit is that as it's spawning these little planes, it actually goes ahead and merges them together. You know, if I understand that this area over here is a horizontal plane and this one is over here, and I start to kind of look between them, you'll see some planes kind of merge together into one single plane there. On the flip side with ARCore, it does it a little bit different. Again, the functionality is the same, but what it actually does is kind of create a mesh and visualize it with a special shader, and then it's more of like a scanning process, where as you move around the room, instead of positioning planes like ARKit does, ARCore kind of builds up the mesh and builds up the plane data. And you can see that a little bit in the GIF down there at the bottom. All right. Whoop. Okay, so hit testing. So again, like I mentioned before, this is kind of the idea of, you know, looking at what you're seeing in the world, kind of understanding feature points, and then kind of using your device as kind of a window to estimate where depth is at. And so basically, the way this is visualized in both of them is kind of as small little dots and points here. And in ARKit, and I'll mention this and kind of show this in one of my demos, ARKit actually uses just a scriptable particle system in Unity. So it just places little kind of yellow particles all around at all the feature points that it recognizes. And then from there, you can do certain ray casts to kind of, you know, cast against that and position objects. But then you can also use those ray casts to look like specifically for planes if you're trying to kind of put objects on the floor. And similarly, ARCore does the same thing. It has little dots through there, and then as it understands feature points, or as it recognizes them to be around the same horizontal level, that's when it starts to build up the planes there. All right, so light estimation. This is, you know, to me, this is really important in kind of selling whatever you're putting in the world and having it understand the environment that it's in. So you can see on the top example there, that basically I have two pieces of pizza. It looks like it's stuttering a little bit, but one is in kind of the lighter area, and then as I move over into the darker area. And similarly, in the bottom GIF there, someone turns the lights out on that lion, and you can see the actual, you know, shader and the light on him go dark. And the way that that works is a little bit different in both of them. ARKit has something called like a script called Unity AR Ambient, and what that actually does is adjust the color for kind of temperature as well as the intensity on a light in Unity. And so commonly you're using like a directional light, which you might consider like the sun. And so it's kind of tuning down and tuning up the light there on those digital objects as it takes kind of this estimated lighting value from what you're looking at in the frame. The next thing, and so on the flip side, ARCore does a slightly different in that they're taking the same sort of estimation where they're looking at what's in the frame, they're estimating the ambient light, but instead they apply it actually at a shader level to kind of dim down shaders rather than doing it with like a directional light. But the feature or the functionality there is similar. All right, so now I'm just going to talk about some tips and things to consider just when developing augmented reality or creating these applications in Unity. So the first thing is just using tracking states. So basically, all of these augmented reality SDKs have certain kind of states throughout they're called a session. So usually when you launch these or when in your application you go over to kind of an augmented reality part of it, then you launch something called an AR session. And through here you can kind of link in and start to get back information from the SDK and then start to communicate that to your user. So basically there's things like, the session needs to initialize, so that takes a little bit of time to load. You can also be moving your device too quickly, and so the SDK will throw back that there's that the motion is too high and things like that. And then there's also the idea of insufficient features. And again, these are just kind of states or kind of the general idea of the tracking, but understanding these and conveying these to your users is always a good idea. If there's not enough feature points or if there's not enough information to start really creating a meaningful experience, then you can kind of let your user know to maybe walk around more or something like that. So just at a high level here, basically with ARKit, we have kind of not available, limited, or normal. And then when you're in limited, you're going to get these different states here for things like when it's still initializing, excessive motion, as I mentioned earlier, and then insufficient features. And one thing to note that I thought was a little confusing is the AR tracking state reason none means that everything is good. So when there's no reason for things to be bad, then things are good. All right, so I talked a little bit about kind of how feature points work, building up planes and things like that. And so when you're placing objects kind of on the ground or on these horizontal objects like a table or something, you often want to wait until you find a plane. That's going to be the most accurate representation as close to the actual kind of horizontal depth of that object. But if you're doing something quick like a measuring application or just kind of smaller one-off applications, oftentimes you don't need to wait for an entire plane to be formed, and you might not even be able to. So if I was going to kind of measure the height of this podium here, I could, instead of trying to wait for a plane to be formed on top here, I could just use a feature point here. And so from this feature point down to a feature point on the floor would be kind of a quicker way to do some sort of measuring app rather than trying to find a plane up here, trying to find a plane down there. So consider kind of using feature points over planes depending on how or what you're really positioning there in the world. The other thing is with these sessions is, and I've gotten some feedback and stuff that people say, my battery drains really quickly or my phone gets hot when you're using these different SDKs. And there is a lot of stuff kind of going on in the back end there with the reckoning between the computer vision and the IMU data. And so what you can actually do is, once you've found a plane or once you've found or kind of placed the object you want, you can then kind of restart the session or you can disable plane finding so that once you've placed something there, you're not continually looking for planes. And with ARKit specifically, it can be a little bit tricky because if I put something on a plane over here and I start to move around and I find a plane over here and then they merge together, potentially my object could kind of jump there in space, and that's usually not what I want as well. So just consider, once you've placed an object, then you don't really need to continually be searching for planes and other things like that. The other thing is, this is just kind of allow basically a session restart in your application. It's always a bad user experience when things aren't working and they have to kind of kill the application and restart it. So there is ways to basically refresh or renew the sessions there. All right, so adding shadows. So basically, we talked about light a little bit. We talked about kind of understanding or emulating the real world here. And so in the ARKit SDK, we have actually a prefab that's basically a transparent object, and then it has a special shader on it that allows light to cast shadows onto a transparent object. So usually in Unity, you can't cast shadows on transparency, but this one specifically allows for it. And what you can do is you can actually easily kind of put this as a child object of anything in your scene, and then you can get kind of fairly accurate or real shadows there. Now, this is going to be a little bit more expensive than something like a blob shadow, which is kind of just like an estimated shadow underneath it, and that actually is what ARKit uses. So it has a similar type prefab, ARCore, and has a similar type prefab that's like more of a blob shadow. But ARKit, we're shipping with this accurate one, so you can really emulate kind of real shadows and shapes there. And one thing to note is that this shadow plane prefab is shipped with ARKit, but there's actually nothing really preventing it or nothing iOS specific that you can't use this for ARCore applications, and I have done that in some of the things I've used. So the next thing is just use real-world size. So in Unity we have this idea of 1 unit is 1 meter, and so just to kind of consider that when you're creating and authoring these AR content applications. So if you make a character that's as big as you, and you spawn him in the real world, he's probably going to be about as big as you as well. So consider that, and I'll talk a little bit in a moment here about kind of scale, but just keep that in mind as you're authoring this content. The next thing, and this is kind of something along the guidelines with these new mediums and things that Apple and other people are suggesting, is think about object interaction, think about input and things like that. So for these AR SDKs, at the end of the day, you're still going to be interacting with them through a mobile device. So you're still going to probably be doing things like pinching or swiping or touching, like tapping and things like that. And so for object interaction, usually when you want to kind of move something around, if you swipe down to move it, you're probably going to want to move it in the X and Z axis and not into the Y axis, which would kind of put it into the ground itself. So just consider that when you're, thinking about input and object interaction to maybe, swipe down, or you almost never really want to go down in the Y depth, because that's going to kind of make objects look strange or go into the ground there. All right, and the next thing I want to talk about is something called Unity ARKit Remote. And I will mention that we're working on a remote for ARCore as well. It has been released and is fairly experimental, but this is just kind of a general tip when developing, and I'll go ahead and show a small example of how this works here. But the general idea is that you can actually set up your Unity editor, drop in a prefab, and then drive the Unity editor through an application or through a device that's plugged into your computer here. So I have my laptop plugged in here, and basically what I can do is I can kind of hit play and then sync my iPad up with a special scene or application that I've built for it, and then it allows me to do much quicker iteration, kind of see what's going on there, and build apps through there. And so something to note with like the 2017.1 release of Unity, we now have this kind of connected player drop down in the console window, and I'll show a little bit of how this works here. All right, so I guess I'll go ahead and try to jump over and show this one first. Just the remote here. So this is just normal Unity editor. This is just a kind of interesting example that I made here. See if we can play. And so you can see here it's saying go to the console and click connected player here. So I can click on that here, and I've launched the kind of Unity ARKit app that I've built out to my device here. Let's see if I can get this going. Oh. There we go. And then now through here, it's going to kind of basically, again, be kind of piping data from the editor to my device here. See if we can get this going. Whoop. A dictionary popped up. Not sure about that. But you can see in the background, let's tab back to Unity. There we go. So what I've done here is I mentioned earlier that the Unity for ARKit just uses a particle system. And so what it does is it goes around and places little yellow particles. And so I've replaced those yellow particles with Unity logos. And so now these are a bunch of feature points that my application is picking up here. And then I just made them rainbows because, that seemed cool. And so you can see here, again, I'm kind of driving things through the Unity editor, but I'm using this connected device here. And so this is something called the ARKit Remote, and this is something we're building out for ARCore as well. And again, this is just kind of an iteration, kind of workflow streamlined thing you can do here. So we can go ahead and undo that. All right, so now I'm going to talk a little bit about some interesting examples. So these are things that are developed inside Unity that are kind of out there in the ecosystem that we're seeing people use, and then just some interesting use cases. So Pokemon Go, when it was first launched, it kind of had its own sort of similar AR solution for trying to estimate and approximate putting Pokemon in the real world. But now it's taking advantage of these AR SDKs, so it's obviously partnering closely with Apple and Google, and now what's happening is that it again kind of finds the plane here, and you can see the Pokeball here after it's thrown out literally kind of rolls on the real world there. And so you'll see that it has a little bit of a blob shadow there, but it really sells this idea with a small interaction of putting this creature here in the world. The other thing we have is something by Normal VR. So they're a company out of New York City, and what they're doing here is they're actually created a small avatar, and they're using ARKit to place it in the world, and then that avatar is actually networked through Unity and being controlled by someone in the HTC Vive. So in a moment here you can see the woman there. She's kind of the one moving around controlling the object, and then this little character here is emulating what she's doing. The other one this is by Ned, just kind of a creative agency out of France, and I'll walk through kind of how this works in a small example that I've set up for it. But basically, what's happening here is that it's kind of like a portal into another world. So on the left-hand side, they've gone down an alley and they've put like a door there, and then they're basically rendering another world through that door. And then when you get close to it, kind of teleports you into that world, and then you're looking back into kind of a portal back into the real world. And so this is something that I've seen a lot of. It's a bit novel, but it can create some kind of interesting effects there. And then the other one, this is by John Sietsma. He's my coworker, and this video was actually captured yesterday here at the conference. And what's happening here is that he is creating a kind of cube reflection map out of what the camera is rendering, and then wrapping that and using it as kind of real-time lighting and reflection on kind of a shiny object here. So you can see as this robot walks past this person here in the red, there's actually some red light that's being reflected onto the robot. And so this again kind of loops back into this kind of selling the idea and augmenting these objects to make them look like they fit kind of in the real world here. All right, so now I'm going to go and demo some applications that I've created. All right, so I'm going to basically get the first one started and then talk through it a little bit here. But basically right now, this is just my iPad here. You can see the planes that have been spawned through there. And so now what I've done is I've just clicked on the plane, and it's going to be spawning an object. Now the object is kind of coming from the sky, which might look a little odd as it just comes through here. But this is something that I played around with really early, is kind of size and scale. So this is obviously like a fairly large spaceship here, but since I've now world locked it in the position, or I've placed it on this plane, which is using those AR anchors, I've spun it around here. Now I can kind of open up the door. And then the interesting thing here is that I can actually just go ahead and walk into it. So you can see over here, and it has like windows, so you can kind of see the audience there. But you can see that I'm just kind of walking through this 3D object that I've just placed in AR. So we'll see how well I can do there. You can see it kind of has a shadow. It looks a little rough, and obviously the shadow's not really being affected by that table here. But again, this application is really not that complicated. It's just a large object that I'm spawning on the plane there. And the SDKs and the kind of example scenes that we offer are basically, for this functionality, I obviously added some things to rotate it and open the door. But the main functionality there is just spawning something when you click on the plane. And so that's, inside Unity, that's as simple as really replacing a prefab. By default, we have like a cube that you spawn there. I just kind of replaced it with a spaceship. So the next one I'm going to do is this guy here. So what this is, again, it's just kind of spawning a simple object, but I've added a little bit of functionality. And one thing to consider is, that when you, let's see if I can get him over here. Right there. All right, so this is like my little fox buddy here. So I can like go here. And he gets excited and walks towards me. And then I have him kind of looking at where the camera is. So he's kind of looking over here. Maybe you guys could take like a crowd selfie here. Everyone smile. There we go. But you can see, again, it just kind of placed an object here. He does have a more realistic shadow, which you can see a little bit behind him. But one thing to note is, because you're moving around in position, because the way all this works in Unity, is that you can actually know where the camera is, or where the device is, or where the user is, and kind of position your content around that. So having him kind of look at me as I do things like that just kind of adds a nice, extra layer of kind of interesting functionality there. All right, so the last one here. This one's a little bit rough around the edges, so we'll see how it is. It's kind of the latest one that I made. I'm first going to search for some feature points. There we go. And let's do that. All right, so this is that kind of portal example that I was talking about. And what I'm doing here is, again, I've spawned this portal in the world, and now as I kind of move around and look at, kind of look down, it's actually relative to where I'm looking, and that's kind of what's really selling this effect. Is I'm not just looking at a flat picture or something like that into the portal. The portal actually has some kind of perspective as I move around and look into it. And the way that this works is it's actually fairly straightforward. What I'm doing here is I'm basically rendering this portal using a separate camera, and so that camera is rendering to basically something in Unity called a render texture. And then I'm simply, applying that render texture as the texture of that kind of cylinder there. But what's happening is that I've basically moved all of that geometry, that little city scene that you sound. I moved it like 100 meters or 100 units away in Unity, and then I offset the camera that's rendering it to that render texture by 100 units in that same direction. But then I still adjust its position and rotation relative to the device camera. So it's kind of like I'm doing a mirrored setup here where my city scene is over here on the right and my normal kind of AR scene is over here, and then I'm kind of mirroring the position there to get that depth. And then I'm using what this camera is rendering over here as a texture in that portal. So that's kind of the idea there, and you saw that earlier with my net example there. All right, so now I'm just going to talk a little bit about looking into the future. So, I've talked about what functionality and what features we have there, and now I'll just kind of say some things that Unity itself is working on. So, if you've ever developed inside Unity, you know that we're kind of really passionate and really excited that we have the ability to kind of build once and deploy to multiple platforms. And similarly to what we're doing with iOS and Android, where when you touch on your device, you're not worried about that native iOS call for the touch or the native Android call through Java for the touch there. You're just looking for Unity input.touch. And so what we're building here is going to be a Unity AR interface that we're calling it, and this is going to be a similar kind of bridge between the two SDKs inside Unity. So inside Unity, you're just going to be looking for an AR plane. You're going to be using AR light estimation. And then on the back end, depending on what platform you're targeting, we're going to pull in the associated SDKs into the features and things like that. And so this is something that was shown off by the engineers working on both the platforms at Unite Austin earlier this year, and is now kind of released in an experimental phase if you wanted to start kind of digging into it. But again, it's having this kind of abstraction layer that we're kind of doing a lot of the heavy lifting for you and allowing you to reach a larger number of devices. And the other thing that we realized, and this actually kind of came from an internal hackathon that the XR team did, is that a lot of times, when you're developing AR content, you really want this more like small diorama type of, experience where you maybe are doing like a tower defense game on this table, or you have kind of a miniature world. And what happens is that in Unity, a lot of the systems really kind of rely on or really want their objects to be at uniform scale, so like 1:1:1 scale. So if you start just kind of taking your entire scene and scaling it down to fit on a table, then you're going to have kind of a bad time. You know, you need things like physics, lighting, nav mesh. A lot of those systems rely on those more natural scales. And so what we're developing is something we're calling AR scale. And what it's doing is it's actually using a 2-camera setup in that you have your content here, you have your kind of tracked camera that you're looking on the world, but what is actually rendering your content is another camera. And as you scale down content, this other camera is getting further away, which makes it look smaller, but allows it to still kind of maintain that uniform scale that you need for a lot of the systems in Unity. And so this is something that we're kind of wrapping up in this AR interface and that we want to, allow users to take advantage of, so that you can, using this, you can then kind of understand the space or the plane that you found, and then scale your content specifically to fit that, using some simple math there. All right, so the other thing, and this is kind of a bit more experimental, it's not necessarily like a feature that we're like fully pushing or supporting, but the talk here at Unite that I gave, this is just a small excerpt from it, they're using ARKit and ARCore for a multiplayer experience. And so what they've done here is they basically both found kind of the same plane and then spawned this tanks demo. And this tanks demo is a free Unity demo that we have for teaching you just normal Unity, as well as we have a multiplayer version. And so they just took that multiplayer version, used the AR interface that they helped develop, and then kind of built this multiplayer application where they're both kind of looking at this world, controlling individual tanks in AR using both the SDKs. All right, so that's pretty much it. Thanks a lot for coming. I think we might have some time for questions and things like that. And so, yeah, if anyone has any questions.
So I'll start. When can we expect the unified API for ARKit for all the AR systems to actually come into the stable version?
It's a little bit hard to answer, and I probably shouldn't say anything specific as far as timetable. I know one thing, just in Unity in general, we're moving a lot of things away from the managed native side, basically from C++ into C# land. And so the ARKit SDK is actually completely open source, just wrapping, with an Objective-C kind of DLL there inside Unity. And so it's actually a little bit more beneficial for the team developing that AR interface to kind of be building it on top of Unity rather than fully integrating it in yet. And so I would imagine when maybe some of these other platforms come out or things start to expand a little bit, that it'll be more integrated as like a built-in component. But yeah, I can't really say much as far as that, but the AR interface is available on either Bitbucket or GitHub right now, and you can kind of reach out to those developers. And one thing I didn't mention is that Jimmy, who's the guy who basically did a lot of the work for the ARKit, is really active on the Unity forums. So if you're trying to do any ARKit development, I highly recommend asking some questions there, and he'll get back to you.
Any specific tips about using the estimated light? Because what ARKit gives you is intensity of the light and the color temperature.
Mm-hmm.
You don't have any dashing support or anything like that. So what do you advise to people if they want to get some directionality into the light?
Yeah, so interesting enough, with the iPhone 10 launch or the iPhone X, there is actually light directional estimation. So somehow and this is kind of the facial recognition API, and so that was actually released really recently with Unity support. And through there, somehow they're telling maybe the shininess on your face and estimating a light angle from that. So potentially you could use some of that, whatever they're doing for that, back into ARKit. But there's nothing really out there to specifically support directionality. The one thing I will say is if you want to maybe set things up a little nicer, you can kind of have the user calibrate or have a adjustment for directional light rotation to have the user emulate where the light's coming from.
Yeah, that's what I'm trying to mostly do. I mean, we just picked the drop shadow because it just works across multiple scenarios as the best.
Mm-hmm.
So the ARKit remote works with wired connection?
Yep. Yeah, so it's basically, this is on Wi-Fi, but this one isn't, but it doesn't matter. So yeah, it's all on wired there. You can do it through the network there as well.
So it can work without wires?
You can work without wires, yes. Yep.
So mostly how I understand how this the ARKit works by detecting features on surfaces, right? So how does it detect planes on floors which are basically featureless, like plane?
Yeah, so I mean, it's always going to try to kind of estimate and find any sort of feature points on there. And then the way that planes are recognized is basically just a collection of feature points around the same depth. Now, detecting feature points on that wall. Now there is a little bit of texture on that wall, but something like a plane floor, there's really no surefire way to detect it. Now, it can pick up inconsistencies with things like shadows and stuff like that. Like it'll recognize, unless you're in like a photography room or something like that where there's completely nothing on the floor, then yeah, it's really not going to pick up much. But it can recognize, a lot of different objects and then do estimation from there.
Another question, can you mix and match ARKit or ARCore with Viewforia?
Yeah, so Viewforia is actually expanding on their platform and what they're doing a little bit, where you can use Viewforia to kind of recognize an image or an object, and then it will kind of fall back to ARCore or ARKit if it's on the supported platform and you've included that SDK. But they are actually working on a similar feature set to ARCore and ARKit that is not using these. So that would potentially expand it and open it up to a large collection of devices. Because if you're familiar with kind of the system requirements on these right now, for the Apple side, it's like the 7 up, and then on the Google side, it's the S8 and the Pixel phones. And so they're obviously trying to expand that. But Viewforia is definitely looking at these and looking to kind of work together with them to better their product with more stability and tracking and things like that. All right, cool. Well, I'll be around the conference, and feel free to come up to me if you guys have any other questions, or hit me up on Twitter or via email. But thanks.